Hello my dear friends, welcome back to the next session, the part 2 of the question bank, solution of the question bank in mathematics provided by the Nagaland Board of School Education. So if you remember, we have finished up to question number 6. So now question number 7, of course, it might feel like that's out of the reduced syllabus, but why I will be doing this is because the first part can be used. Okay, it can be used also because as it says, if the first and the last terms of the AP are 17 and 350 respectively, if the common difference is 9, how many terms are there? Now that can be used. How many terms are there? So that's a part of the first exercise also. So this first part of the question can be used. Okay. So since we'll be doing it, we'll be just finding out the sum also. All right. So let's continue. So before that, those who are watching the video to learn, please do share with maximum of the students. Some maybe may not have any source. Everyone is not as lucky. So please do share this video with with your friends also, and yes, if possible, do like also. Okay, all right. I mean those who are watching to learn. The first and the last terms of an AP are 17 and 350. So it's given that the first term is 17. The last term, nth term, we do not know how many terms are there. Okay, so let there be n terms. So n terms means the last term definitely is the nth term, will be 350. So if we can just solve this, a plus n minus 1 d is equal to 350. First term, it's already given to us 17. N minus d, common difference, I saw it somewhere, given 9 is equal to 350. So okay, solution, as I say, simplification and all, we can do it in our own ways, so that you can see how you can do. So n minus 1 equal to 350 minus 17, 333 divided by 9, I'm just cross multiplying 9. So n minus 1 is equal to, if you divide 333 by 9, how much? 9 3s are 27, 9 3s are 27, 28, 29, 31, 32, 33, 63, 9 7s are 63. So n will be 37 plus 1. So that is how much? 38. So there are, since we have assumed that there are n terms and the nth term, that is the last term, is 350, that means n is how much? 38. That means there are 38 terms. Alright, so we will just go on to find the sum also. No problem in learning something extra. May not, even though it's not asked for the exams. So sum of 38 terms, we will be using this formula, n by 2 n plus l, Sn. So that is, sum of 38 terms is 38 by 2 into a plus l is the last term, that is 350. So that will be 19. So that's like 19 into 367. 19 into 367. So that will be 6,973 after multiplication. Okay. Alright, those are finished. You can pause the video there and then you can note down. Alright, I'll rub it off. Now we'll move to the next question now. Next question is number 9. Find the ratio. That's the coordinate geometry from the chapter of coordinate geometry. That is, find the ratio. I mean, not number 8, of course, that's purely find the sum of the odd numbers between 0 and 50. So that's completely out of the reduced syllabus. So that we are going to skip. Okay, question number 8. We'll move to now question number 9. Find the ratio in which the line segment joining the points, in which the line segments joining the points minus 3, 10 and 6 minus 8 is divided by minus 1, 6. So what they're asking here is find the ratio in which line segment joining the points, let's say A minus 3, 10 and B 6 minus 8 is divided by the point, let's say P minus 1, 6. So let the ratio be K is to 1. So solution, let's P minus 1, 6 divide the line joining A minus 3, 10 and B 6 minus 8 in the ratio, let's say K is to 1. So our job here is to find the ratio using section formula. Using section formula, what we know is x is equal to what? mx2 plus nx1 divided by m plus n. Now respectively, what are the ratios here? X represents what? Minus 1. So minus 1 is equal to, what is the ratio of m? We are using k is to 1. So the ratio of m, value of m is k. x2, that's the second point, AB. x2 is 6 plus n, m is to n. So n here is 1. x1, that's the first point, minus 3 divided by m is to n, that is k, m plus n, that is k plus 1. So that, if we solve, if we just cross multiply this value up there, so that will be minus of k plus 1 is equal to 6k minus 3. Simplifying, minus k minus 1 is equal to 6k minus 3. So that's like minus k minus 6k is equal to minus 3 plus 1. So that will be minus 7k is equal to 2 minus 3 plus 1. So that's minus 2. So k is equal to minus 2 by minus 7. So that's, in other words, k by 1 is equal to 2 by 7, or the ratio k is to 1 is nothing but 2 is to 7. That means the point P divides the line joining AB into 2 parts and 7 parts, the line AB, 2 is to 7. Okay? Alright. Number 10. Find the area of the quadrilateral whose vertices. So this is also from the reduced part of the syllabus. So we are going to skip number 10 also for this year. Number 11. If 3 cot A is equal to 4, then prove that 1 minus tan square A by 1 plus tan square A is equal to cos square A minus sin square A. So here the angle considered is A. So what we are going to do is we are going to assume a right angled triangle with the reference angle as A, and the other sides can be any value. So let me start. Consider a right triangle ABC where B is 90 degree. Alright, and A is our referred angle. 3 cot A is equal to 4. So that means cot A will be equal to 4 by 3. Or in other words, tan A will be equal to 3 by 4. Because we know that, okay, I'll just write once again. We know that cot and tan are reciprocals of each other, isn't it? So, or in other words, cot A is nothing but 1 by tan A. Come on, yeah, 3. So, taking reciprocal on both sides, 3 by 4. I'll just mark this as equation 1 because this term also we might need, because tan A in the proof we need. Okay, so that might also be helpful. But again, further I will continue. tan A is equal to 3 by 4. Now the ratio for tan A is perpendicular height by base or opposite side by the adjacent side. So that's going to be what? BC by AB. So you just cannot take directly BC as 3. You are supposed to take the ratio constant. Okay, it is mathematically you are expected to take the ratio constant. That's what we have been learning. You just cannot take, you should not take BC as directly 3 and AB as directly 4. This is a ratio, so we need to respect the principles of mathematics. So now using this, because in the proof we need cos and sine. So for finding out cos and sine, we need the hypotenuse also. So BC we will assume 3k, AB we will assume 4k. We're using Pythagoras Theorem, we'll find out AC by Pythagoras Theorem. What we know is square of hypotenuse is equal to sum of the other two sides. So that is BC is what? 3k square. AB is 4k square. So AC value we get 5k. So now let's go for the proof. Left hand side 1 minus tan square A by 1 plus tan square A. So for this, it is already given in the question that tan A is 3 by 4. So we are going to use, but it is square. 1 plus 3 by 4 whole square. That's why we are trying to make our problems simple. So 1 minus 3 square 9 by 16. 1 plus 9 by 16. So now simplifying, common LCM, LCM 16. So 16 minus 9. Here also LCM 16. 16 plus 9. So 16 denominator done. 16 minus 9, so that's 9, 10, 11, 12, 13, 14, 15, 16, 7. Chalk has to fall every time. Okay. 7 by 25. Alright, so this is our left hand side. Alright, okay, so now we will go for the right hand side. The right hand side of the statement, that is cos square A minus sine square A. Now from this triangle it's already solved. So cos is what? As we say, base by hypotenuse or adjacent side by the hypotenuse. So that's going to be 4k by 5k whole square. Minus sine is altitude, opposite side by the hypotenuse. So that's like 3k by 5k the whole square. K I can just cancel it here. So 4 square is 16 by 25. That's why this ratio constant k actually doesn't give us any problems, okay? But it makes our problem definitely mathematically very much correct. That's why. 25, 16 minus 9, so that's like 7 by 25. So you can see that the left hand side and the right hand side are same, that which is equal to LHS, hence proved. Hence proved. Alright, so I'm rubbing it off. Alright, moving on to the next question, that is number 12. Prove that 1 plus sec of A divided by sec A is sine square A by 1 minus cos A. So let's go for the left hand side. 1 plus sec a by sec of a. So since we have to prove in terms of sine and cos, sec we can write it as 1 by cos a. 1 by cos a. So on the numerator, taking the common LCM, cos a, so that's going to be cos a plus 1, taking the common LCM here, 1 by 1, and here of course 1 by cos a. So further solving, cos a, denominator we can cancel, so we are left with cos a plus 1 or 1 plus cos a. You can go for the other part of the proof from the right hand side also, or you can just continue from here also. Okay, but I'll continue from here. I'll not do the right hand side separately because it's very easy to solve also. So now what I'll do is divide by 1. Now what I'll do is we can do this. Okay, I will multiply and divide by 1 minus cos a. These things can be done mathematically, no problem with that. I'm multiplying and dividing by the same term. So when I do this, definitely the value of this equation doesn't change because I can just cancel this 2 again, so it's the same. So just to get my solution, we can do this, right? For example, 3, without changing its value, we can do many adjustments. Transformation, that is 3, I can write it as, I can just multiply and divide by 7, multiplying and dividing by 7 because 7 sevens are 1, so it doesn't make any difference. 3 remains just 3 only. Okay, it's almost similar to the process of rationalization, componendo and dividendo. Not exactly, but like rationalization as we have already done. So, but of course, if you want to wish to take the from, you can leave it here and then, okay, let us do one thing, let me not confuse you. Okay, so let us keep it as it is, the left hand side. Most of you, because in the textbook the hint is given, take the right hand side separately. So most of you may have been doing by taking the right hand side also. So I'll just do it that way. So RHS, sine square a by 1 minus cos a. Now from trigonometry formula we know that sine square a is 1 minus cos square a, the trigonometric identity. So I can write it as 1 minus cos square a divided by 1 minus cos a. So now 1, if we can write 1 square, isn't it? And we know the formula again, a square minus b square is nothing but a plus b into a minus b. So 1 square minus cos square, that is a plus b into a minus b divided by 1 minus cos a. 1 minus cos a, 1 minus cos a. So here also what do we have? 1 plus cos a, so that is equal to the left hand side. Proof. This was the left hand side. Now, alright, so this is how the proof can be done. Okay. Alright, moving on to the next question. 13. Again, prove that cos a by 1 plus sine a plus 1 plus sine a by cos a is 2 sec a. So let's take the left hand side. Okay, you can note down the question. Done? Alright, so I'll just start with here. Lazy person, so lazy person will just start from the question. LHS. Now we'll have to take the LCM. Different terms, so LCM is product. 1 plus sine a cos a. So this will be cos a into 1 plus sine a is already here, so I'll have to multiply by cos a plus 1 plus sine a. Cos a is already present in the denominator, so I'll have to again multiply. Common concept of LCM, sine A. So cos A, that is cos square A plus this one. If you wish, you can just multiply 1 into this, or you can just use the formula of this into this. Sine A, sine square A. You can even use the formula of A plus B whole square. Cos A, 1 plus sine A. Now these two I'll arrange together. Nothing much, I'm just arranging. Plus 1 plus sine A, that is 2 sine A, all divided by cos A, 1 plus sine A. Got that? Okay. Those who have not finished, you can just pause the video there and write it down. Done? Okay, I'm rubbing it off. Now sine square A plus cos square A, sine square theta plus cos square theta, the first trigonometric identity, that is 1. So 1 plus 1 plus 2 sine A. Cos A, 1 plus sine A. 1 plus 1 is 2. Now taking 2 common, I have 1 plus sine A, cos A, 1 plus sine A. 1 plus sine A, 1 plus sine A, so I'm left with 2 into 1 by cos A. So now 2 into 1 by cos A, 1 by cos A is what? Sec A. So this is our right hand side, hence proved. Okay, rubbing, pause and rubbing. Okay, next, number 14. Evaluate sine 30 degree plus tan 45 degree minus cosec of 60 degree divided by sec 30 degree plus cos 60 degree plus cot 45 degree. So we'll have to remember the values. So let's begin. Sine 30, 1 by 2, tan 45, 1, cosec 60, 2 by root 3. If you forget the value for cosec 60, you can always remember the value for sine 60. What was sine 60? Root 3 by 2. So cosec 60 will be just the reciprocal of sine 60. Sec 30 also, again, you can, if you find it difficult, cos 30. Cos 30 is also root 3 by 2. So sec 30 will be reciprocal, 2 by root 3. Cos 60, 1 by 2 minus plus cos 45, 1. Now let's take the LCM numerator. LCM 1 means 1 by 1. So 2 root 3. So 2 is already here. So here I'll multiply by root 3. Here denominator is 1. So 1 into 2 root 3. Plus here we have already root 3. So this 2 I'll have to multiply by root 3 is already there. So LCM again I have to multiply by 2. Similarly here also LCM 2 root 3. So root 3 is already here, so I have to multiply this 2 with 2 plus 1 into 2 is already there, so 1 into root 3. This one 2 root 3. Denominator, same denominator sign. So what is left? Root 3, 2 root 3, same family, like terms, so that is 3 root 3 plus 2 2s are 4. Again plus minus, no? Minus. This one same, 4 plus, so I'll just arrange 3 root 3, this plus this, 3 root 3, 2 plus 1 3 plus 4. Now this one I will have to rationalize. So how do we rationalize? By multiplying and dividing by minus 4. If it is plus, this will be minus. I'll have to multiply and divide by minus 4. If it is plus, minus. If it is minus, plus. Multiplying and dividing. Rationalization. We have done lots enough in class 9. So, okay, I can just still manage here. So that's like root 3 minus 4, 3 root 3 minus 4. So that's like 3 root 3 minus 4 whole square. Isn't it same terms? This is 3 root 3, 4, 3 root 3, 4. So it's like a plus b, a minus b. So the formula is a square minus b square. So a minus b whole square formula, a square minus twice into a into b plus b square. This is 3 3s are 9 into 3. 3 square is 9, root 3 square is 3. Minus 4 square, 16. So same, 9 into 3 minus 2 3s are 6, 6 4s are 24. Root 3, I cannot multiply this with root 3. I have to leave it as it is, 16. 27 minus 16. 9 3s are again 27 minus 24. Root 3 plus 16 divided by 11. So now 27 plus 16, 13, 2, 3, 43 minus 24, root of 3 divided by 11. So this is the solution for, more than trigonometry, we require more of simplification compared to trigonometry. So your simplification concept has to be also very good. You have to be good in arithmetic. What I mean to say is that. Okay. All right. Next, moving on to the next question. Now construction, the next question is about two questions. Number 15 and number 16 are constructions. So construction, it is kind of very difficult for me to solve here. But number 16, of course, I believe would be important because this time drawing of triangles and all are from the reduced syllabus. So you have basically the tangents, which is very important for construction. So without fail, you should study this question. Number 16, of course, they are that particular exercise also, construction of tangents. All right. So construction is kind of like without the compass and all, it's kind of difficult for me. So I'll just skip that question. We can try. I believe that would be very easy for you also. Let's go to number 17. What it says is a chord of a circle. A chord of a circle of radius, let's say that the chord. A chord of a circle of radius 15 centimeter subtends an angle of 60 degree at the center. Find the area of the corresponding minor segment, not sectors, segments, of the minor segments and the major segments of the circles. Of course, using pi equal to 3.14 and root 3 equal to 1.73. So if in the exams, if this kind of terms are given to you, that use pi equal to 3.14, please do use it, not 22/7. Okay? Alright. So, okay, I will have to write down the question, isn't it? A chord of a circle of radius 15 centimeter subtends an angle of 60 degree at the center. Full stop. Find the areas of the corresponding minor and major segments. You should use pi as 3.14 and root 3 as 1.73. So these are the terms given to us. Let's begin. Solution. Radius is 15 centimeter. Central angle or angle of sector is 60 degree. We'll go straight. Area of minor segment. You can use this formula for finding out the area of minor segment. Okay, instead of deriving it, just use this formula. That's pi theta by 360 minus sine theta by 2. Theta is the angle of the sector into square of the radius. So you can use this formula directly to find out the area of the minor segment. Okay, instead of deriving it. This is the best. So that's like pi value 3.14, theta 60 divided by 360 minus sine 60 divided by 2 into square of the radius. Radius was 15 centimeter whole square. Job is to now solve this. So that's like 66 times 2 3s are 6, 1.57. So that's, we are left with 1.57 divided by 3 minus sine 60 is root 3 by 2 into denominator also we already have a 2 into 115 square 225 centimeters square. So we'll have to take the LCM. Okay, one more step. 1.57 by 3 minus root 3 value 1.73 divided by 4 into 225 centimeters square. So the LCM is 12. So that's like 1.57 into 3 4s are 12 minus 1.73 into 4 3s are 12 into 225 centimeter square. Now let's simplify this. 4 7s are 28, 2 left, 4 5s are 20, 21, 22, 2 left, 6, 6.28 minus 3 3s are 9, 3 7s are 21, 2 left, 5.19 divided by 12 into 225 centimeters square. 3 4s are 12, 3 7 5. So now, if we subtract 6.28 minus 5.19, so it's 18.1, so 9.01. So like 1.09 into 75 divided by 4 centimeters square. So I'll just do the simplification also quickly for you. 5 9s are 45, 5 1s are 5. 7 9s are 63, 7 1s are 7. So that's like 5, 7, 11, 1, 8. 81.75 divided by 4 centimeters square. So now if we just divide 81.75 divided by 4, 4 2s are 8. 1, not possible, so I'll have to put in 0, decimal comes 7. So decimal starts. 4 4s are 16, 1 5, 4 3s are 12, 3 0, 4 7s are 28, 2 0, 4 5s are 20. So the area of the minor segment is 20.4375 centimeters square. This question actually I would suggest it should be in the 5 mark section, not 3 mark, because again we have to continue with the area of major segment. This is just the minor segment. So I believe most probably you might get this in 5 mark question also, so you can just be prepared with this particular question. Alright, now next area of major segment is equal to, now for area of major segment it's very easy, because you see from a triangle a chord divides a circle into two segments, major, minor. So area of major segment will be nothing but area of the circle minus area of the minor segment. So that's area of circle minus area of minor segment. Area of circle pi r square. Area of minor segment we already calculated, 20.4375 centimeters square. So let's solve this again. So that's like 3.14 into 15 centimeters square minus 20.4375. So that's like 3.14 into 225 centimeters square minus 20.4375 centimeters square. So if we just multiply this, 3.14 we'll have 706.5 centimeters square minus 20.4375 centimeters square. We can multiply 314, 2 decimal, 225, 5 4 are 20, 2 left, 5 1 5 6 7, 5 3 are 15, 2 4 are 2 1 are 2, 2 3 are 6, 6 2 8, 0, 15, 1 left, 8 9 10 16, 1 left, 6 7 8 9 10, 1 left, 70, 2 decimal, 706. Now subtracting 20.4375, 2 more decimals. So it's like 5, this is 9, carry over, 2, this is again 9, 6, this is 4, 0, 6, 10, carry over, 8, 6. So that's like 686.0625 centimeter square. 686.0625 centimeter square. Alright, so this was question number 17, wasn't it? Yes. So we'll have to do another session, the part 3, where we'll try to wind up all the questions from question number 3. So it's almost been 40 minutes, so I think this session would be enough. Alright, so till then, practice well, all the best for your examinations. I'll see you with the third part of part 3 mark questions, with hopefully should be the last session for 3 marks. After that again we will move on to 5 mark questions also. Alright, so till then, study well, come prepared. Next session with question number 18 will be out of the syllabus, 19. Okay, alright then, bye bye, see you soon.